Station, this is Houston. Are you ready for the event?
Station is ready for the event.
Houston ACR, this is Mission Control Houston. Please call Station for a voice check.
Station, this is Houston ACR. How do you hear me?
I have you loud and clear. How about me?
I have you loud and clear. Please stand by for opening remarks.
Hey everyone, I'm Kentucky Governor Andy Beshear. I want to welcome the students, educators, and leaders from NASA here today to this incredible experience. As governor and as a dad, I love to see how we're taking education to the next level, and this is just about the coolest thing I've ever seen offered to our kids. I'm so proud Kentucky is a part of it. Thank you to NASA and to the Challenger Learning Center of Kentucky for making this possible. Now, let's get to the important part and learn more about these amazing astronauts in space. Have fun.
Hi, my name is Natalie, and my question is, what was the most unexpected thing about space or space travel?
Hi, Natalie, and hello to everyone out there in Kentucky at the Challenger Centers. I just want to say I'm so excited to be speaking with you all. I know it's been a challenging past few weeks for you all there, and just hope that today can be a little bit of an escape and we can have a little bit of fun together. So Natalie, to answer your question, I think the most surprising thing about space travel has been how quickly our bodies adapt to this new environment. We first get here, and of course it is totally foreign to us. We don't know where to put our hands or our feet or how to get around, and in just a few short days, it seems that our brains are able to figure it out. We can understand that everything is happening in 3D and how to use the whole volume and learn how to translate around, as well as our bodies start to adapt as well and start to really be able to function efficiently and effectively in the microgravity environment. So that has been a pretty neat process to watch.
Hi, my name is Xavier, and I was wondering, how does welding in outer space work on the International Space Station?
That is a really interesting question, Xavier. It is definitely going to be really important moving forward as we start to explore further and further into the solar system, that we invest in new technologies in welding and things like additive manufacturing that will help us be able to build in space. So rather than having to rely on cargo resupply vehicles, which will be increasingly difficult as we get further away from the Earth and start to think about the Moon and Mars, having the ability to manufacture in situ, in process, is going to be really important as we start to want to be able to build things like at a lunar base, for example, in our Artemis program. So we're definitely testing out those technologies here on the ISS. We have a manufacturing device actually just right here next to me that's working out some of those ideas, looking at fiber optics as well, 3D printing. It is all super exciting and will be super important in the future.
Hi, my name is Maddie. My question is, what is one of the procedures for a medical emergency?
Yeah, great question. So we all kind of get basic training in medical emergencies, medical procedures. So we're all able to take care of each other on kind of a basic level. Luckily for us, one of my crewmates, Chell Lindgren, who's actually just behind me, if you can spot him, but he is a medical doctor, and so we are super lucky to have him on board, just to know, hopefully we won't need to rely on his skills, but it's nice to know that he has them just in case. So I brought a couple things to show you here to give you an idea of what our medical procedures are like. So we have a procedure book here that tells us exactly what to do if we get into a situation where we need to use some of these medications. And these medications come in a kit like this. So it looks like something like this, and then you can open it up. And we've got everything that we might need for that type of situation available to us here. And so, of course, a lot of these we would be talking to our surgeons on the ground, our flight surgeons, who would tell us exactly what medications to administer. But we are hopefully not going to have to use any of our training or our equipment in terms of medical emergencies.
Hi, my name is Natalie, and my question is, what happens when an experiment fails?
That's a great question. We do lots and lots of scientific experiments up here, and really there's almost no way that an experiment can fail, because even if an experiment doesn't produce the results that we expect, we still learn something from that. And that is just the part about science that I personally enjoy the most, is that we actually end up learning the most when things don't go quite as planned, or things don't turn out exactly the way we expected, because then that means that we are learning something new that we hadn't considered before. And that happens a lot here in Space Station, because we are really pushing the bounds of our understanding, and especially our understanding of things in the microgravity environment. So as we look at biology and chemistry, Earth and space science, we are learning new things every day, and sometimes that means that our experiments don't go exactly as planned. But we are always pushing, always learning, and it's exciting to be always a student up here.
Hi, my name is Savannah. My question is, with space tourism on the rise, what would you recommend for someone traveling to space?
Good question. So if you are planning to travel to space in the near future, I recommend several things. One is to make sure that you pack lots of photos of your friends and family. Myself and all of my crewmates have plenty of those, and helps us keep connected to the ground. I would say also make sure that you have some of your favorite foods coming up with you, or coming before you. In our case, we have lots of delicious treats up here to keep us happy. We have mac and cheese. We even have burger patties that we can make, put them in a tortilla, and they're delicious. And lastly, I would say if you were planning to travel to space, I would say stay a while. We get to be up here for 6 months on our Expedition 67 mission, and it is just in that time that we can really fully adapt to the environment, fully kind of be a part of it, and learn to use it to the best of our abilities. And that's really when we can be the most efficient, get the most work done, and also get to observe the Earth for the longest period of time, which is a nice little benefit.
Hi, my name is Joseph, and I was wondering what would happen if you ended up letting go of a helium balloon while on the International Space Station.
It's an interesting question, Joseph. So actually, it would probably be somewhat anticlimactic if you filled up a balloon with helium on the ISS, because what would happen is the same thing that would happen as if you blew up a balloon with your own breath, with air. Of course, on the ground, if you fill it up with helium, helium is lighter than air, so the balloon rises. But here, that difference doesn't matter, because we're in microgravity, and so the two balloons would move away from you kind of at the same velocity, and they wouldn't necessarily go up. There is not really an up here on Space Station, and so they would kind of disperse in whichever direction that you release them to, and they would just keep going until you stop them.
Hi, I'm Isaac. Do you ever hear or see space debris while on the International Space Station?
Yeah, it's a really good question. And so we definitely are aware of space debris while we're up here on the International Space Station. It's important for our safety to be aware of what's going on outside of the station. And so luckily for us, we have a super expert team of people on the ground who are looking out for us. So we have a kind of perimeter around the station, if you will, where this ground team is is constantly monitoring to make sure that any objects that we are aware of out in space are not going to make contact with the space station, that their pathways are not going to collide with our pathways. And if that is the case, if we see that some small piece of debris might intersect with our trajectory, then we can just move the station out of the way. So we can fire our thrusters and either go above or below any piece of debris that might be have some potential for coming in contact with us. So that helps us keep us safe and definitely gives us peace of mind being up here.
Hi, my name is Kendall, and my question is, what was your favorite part of the training that you had to go through to get into space?
That's a hard question, Kendall, because all of our training was super fun. I think one of the most rewarding parts of our training is our spacewalk training. So we train for what we call EVAs, or extravehicular activities. So that's when we get to go outside and do spacewalks. And so how we train for that is we have a giant pool out in Houston, Texas. It's called the Neutral Buoyancy Laboratory. And in this pool are large mock-ups of each of the outsides of the modules of the space station. And so we put on our spacesuits, our EMUs, and go down into the water. It is about 40 feet deep that we go down, and that is where we can learn and practice moving around outside the space station, doing the maintenance that's necessary outside. So that was a really awesome part of our training, but we also thoroughly enjoy all of it, getting to train on our SpaceX Dragon, which is the launch vehicle that got us here and will get us home. Training with that team in Hawthorne at SpaceX was super fun, as well as getting to train with our international partners, getting to do a bit of international travel to learn about the different modules like this one. I'm in the Columbus module, which is the European Space Agency module. So our training is very varied. There's a lot to do, a lot to get done, but it's super fun.
Hi, my name is Cash, and my question is, how would glue react in a microgravity environment?
Yeah, so believe it or not, we actually have quite a bit of glue up here, hidden in plain sight. So we have lots of materials, lots of equipment that is made with glue, or glue's involved in the process of manufacturing it, and then it gets sent up here. So that we rarely, I think, actually use glue to fix things, though we could, but we certainly. Glue is up here and kind of around us everywhere. So once it is adhered to a surface, the adhesion force of the glue is strong enough that it will not have an effect up here in microgravity. But certainly if we were to squeeze a glue bottle, like a little Elmer's glue bottle, we would have to be ready, because we would definitely see the droplets kind of go everywhere, and then it would stick to the walls and everything. So we would have to be on our toes.
Hi, my name is Sebastian. What has been your favorite experience while on the International Space Station?
Another tough question, because everything about being on the International Space Station is awesome. But for me, I am a geologist by training, and so for me, being able to look out the window and seeing the Earth, especially from this perspective, being able to see places where I've done field work, I've studied from on the ground, being able to see them from up here, from the vantage point of the ISS, is just absolutely awesome. The Earth is so beautiful, and the surprise for me was that the moon is also gorgeous, and sometimes even steals the show.
Hi, my name is Jonathan. My question is, what is the most challenging daily task on the International Space Station?
I think honestly, probably the most challenging tasks sometimes can just be your average everyday pieces of life. Of course, after being up here for a long period of time, we definitely get used to it. But when we first arrived, even just things like preparing and eating dinner can be a real challenge. Learning how to manage 7 different small bags of food that are all floating, and food is floating out of the bag, and how do you keep that all together around the table, things like that. Learning just even how to get around without crashing into everything and crashing into your friends. Learning those kind of basics all over again is definitely a challenge when we first arrived.
Hi, my name is Allison. My question is, what is the most difficult thing you had to overcome during training?
I think the most difficult part of training was not any one particular aspect necessarily, but just the combination of all of the different things that we had to learn and show proficiency in during training. So just kind of the whole totality of training and just the diversity of the different aspects of training. So on any given day, you could have 7 different activities that were learning how to use the robotic arm during 1 hour, and then the next hour you are flying a T-38 jet, which is what we use to get some especially work on our crew resource management is what we call it. And then the next minute we could be learning how to conduct a scientific experiment up here. So just kind of keeping all of those juggling all of those different aspects of training all at once was maybe the most difficult.
Hi, my name is Nathan. How does inertia feel?
Yeah, well, I should be asking you the same question, because I guarantee that you have felt inertia as well. But it definitely is different up here on the ISS. It's certainly true that when you, as I was talking about with the balloons, as soon as you let go of something, or even this microphone, it's going to continue moving until I input a different force on it. And so learning that about different objects is definitely a learning curve. I've definitely lost a few items up here. You look away for 1 second and it's gone. So definitely inertia it can be your friend if you can wield it properly, but it can also get the best of you if you're not careful.
Hi, my name is Will, and I would like to know how you keep time on the International Space Station.
Yeah, so we actually are on Greenwich Mean Time, and so that is actually, I believe, 4 hours off of Kentucky time, and so that is the time zone that we essentially elected to use up here, and that is the time that the ground team uses to help keep us in line, keep us on schedule, and all in sync on our timelines.
Hello, my name is Kelsey, and my question is, what is the most challenging part of adapting to microgravity?
Yeah, so I think there are a few aspects to it. One, I've kind of touched on the idea of kind of remapping your brain to be able to use all surfaces around you, both the floor, the ceiling, and the walls as free game. That's definitely a process that happens while we're up here. The other part of adapting to microgravity is kind of happening a little bit more without us knowing. So we know, based on scientific studies and previous spaceflight, that while we are up here, our bones and muscle strength and health can deteriorate just as a result of being in this environment and being without gravity. And so while we're up here, we participate in what are called countermeasures. So effectively just exercising, getting good cardio activity, as well as weightlifting, getting some actual weight on our backs, and that is to help counteract this bone loss potential. And so if we were not engaging in that activity, that would definitely be something that is happening to our bodies as a result of being in microgravity. And so doing all of the exercise that we do is a means of adapting to this environment so that when we get back, we are nice and strong, our bones are not brittle, and we are ready to hit the ground running.
Hello, this is State Senator Brandon Smith. I want to give a special thank you to the astronaut and crew that made today's event so successful, but it wouldn't have happened without the Challenger Learning Center of Kentucky. This is the true winning team for all of us. Thank you, guys.
Thank you so much for your time today. It's great speaking with you.
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you to all participants. Station, we are now resuming operational audio communications.